Hello and welcome to part 4 of Quantitative Research Design, where I continue the introductory look at different types of design by moving on to experimental research design. So we've got examples from physics, medicine, social science. What we're really looking at is which one is giving a really compelling account. Okay, this thing is true. You just have to believe this. Yeah. You can't just say, oh, maybe I'll look at a different point of view. Maybe this doesn't work, maybe it does something. The first one is physics. Whatever you think about it, it kind of does stuff. Things happen. It's not just like bang the rocks together, guys. It does stuff. And the same with medicine. Okay, some people do deny this, but there were tremendous numbers of deaths from measles. You can do the same with polio. You can do the same with smallpox. And then you get the date the vaccine comes out, and suddenly it goes off a cliff. And that makes many people think, yeah, okay, something's happening here. So how do you get that kind of? Here's a bit of research. This is doing stuff that you can't deny in social sciences. Well, we've got the livelihoods theory, not the livelihoods theory, sense, capabilities and functionings approach, entitlements. So everybody agrees in international development. This is a really insightful piece of theory. It's probably the most well-known and most widely used theory kind of international development. And Sen is maybe the doyen, the most intellectually admired, amazing scholar in development, Amartya Sen, and certainly deserves it, amazing. But does it really convince you this must be true in the same way that this or this does? Is it as compelling? Can we make it as compelling with experiments? So, experimental research design, the common phrase is the gold standard for empirical research, empirical meaning dealing with evidence. And in the natural sciences, it's ubiquitous. I mean, you know, in the natural sciences, if you say, okay, I wonder if this semiconductor is going to be more efficient at conducting electricity without getting hot or at low temperatures. Okay, let's do a survey of what people think. No, that's not what you're going to do. You're going to experiment. But in the social sciences, it's been much more recent and limited, even though it's spreading very fast. It's particularly where causality, internal validity, is a central concern, which it is for social sciences that wants to inform policy, because we really want to know, if you do this, what's going to happen from that? And why is it difficult to establish? Well, the school toilets example is there. There's problems in both designs that could be addressed by making it more experimental. And the problems in both designs are you don't know those two groups are equivalent. So if you've got the with and without comparison, is the effect because of the toilets, or is it because that group of schools were different? When you have the before and after comparison, you have to, okay, would that have happened anyway because of some other factor? Experimental design would help. And an RCT is a randomized controlled trial. That design is shown like this. So the difference here is, instead of the officials putting things into two groups, you randomize it using a dice or a computer. You randomize the selection between the two groups, and otherwise do the same thing. So they get the toilets, they get nothing. Control group, they measure. Examples of actual randomized control trials. This is just a sort of made up kind of example, although based on a real situation. It's not a real piece of research. So the real examples we have in week 3. First, you might want to pause and think, what are the pros and cons? We'll come back to this in week 3, but what are the pros and cons of experimentation for studying the problems of poorer and developing countries? So pause and think about that. And then finally, the last ones we have today is these quasi-experimental research designs. I think in English it should be quasi-experimental, but it sounds quasi-experimental sounds more better. So why is this needed? Well, as you might have thought if you paused the video just then and thought, what are the pros and cons of randomization? Well, you can't randomize gender, ethnicity, and caste. They're just as they are. It wouldn't be ethical if you could. Drug taking is one example. You have to force people to take drugs for a decade and then see how their life is after that. That wouldn't be okay. So some things you can't do or you mustn't do. So quasi means almost or nearly. So you're trying to get as close as you can to an experimental situation in some way. So it could be that nature makes the intervention X. So instead of you doing something, you wait for something to happen randomly. Randomly is not a good choice of word. I should pause the video and delete, but I probably forget to. nature makes the intervention without human intervention, so it's not purposeful, and you can treat that as though it's random. Or if you can't get rid of non-random effects, then you have to use statistical techniques to try and compensate for the fact it's not random, if you can't assume that nature is allocated randomly. And we'll have examples of these. In actual fact, you'll spend a lot of time on these in the semester because it's often very difficult to do an experiment. So here's an example of what it would look like in this notation, if you can assume that there's a natural experiment, so nature is randomized. There was a well-known study by Bossier and others in 1985 looking at Kenya and Tanzania, two countries next door to each other, and they had all these very similar things, very similar agroecological range of environments, resources, colonial experience, both European, dominated by Tanzania by the Germans and Kenya by the UK, and then latterly Tanzania by the UK as well. Everything's the same, but after independence, they went completely different ways in terms of post-primary. In Tanzania, Mwalimu Nyerere said that most of our people are rural, they're living in rural areas. They don't need to be educated in like engineering, they need to be good farmers. So they went for mostly emphasising primary and education about farming and self-reliance, whereas Kenya, they tried to go, okay, down the more sort of traditional or more like Western, people going through secondary and into primary, secondary, tertiary education. So quite quickly it moved to these big disparities, like 6 times difference in the figures. And Bossier and Knight found that there were substantial differences, as well as in earnings between people, also in cognitive ability in terms of different tests. And they claimed that these were caused by the different education policies, because everything else about the two countries is the same. So the earnings and cognitive ability must be caused by the education policy, because that's the only thing that was different in the two situations. And by the way, they argued that against that. This shows that a credentialist view of education, credentialist means that it doesn't really, the higher earnings people get from education is not primarily because they're more productive having had the education, it's because it just signposts them and lets them stand out in the employment market and sort of signals that maybe they come from a certain background or that kind of thing. It's not the essential worth of the education itself. The next one we can look at is what's called non-equivalent groups design. You might think it's similar to the toilets example, where these are being allocated through non-random methods, and that's true. I've put in here an extra level of pre-test, which clearly makes sense. But even here, the problem is that you can't assume that the other factors are similar in each group. That's why you need to have these observations here to try and check how similar they are, and then complicated statistical processes to compensate for any differences you find here between the two groups. So the differences between the groups can cause you to pick up differences here, and also different changes between here and here because the groups are different. So two popular ways of dealing with this are what's called the difference in differences method, which everybody calls diff in diff. So diff in diff means differences in differences, or propensity score matching, or PSM. And we'll have more of those later. There are many others. There are things called observational studies, you'll hear referred to, correlation analysis, and there's more inconsistency in terminology. Part of the inconsistency in terminology, I think, is because the people that really think experiments are the only way to go have made up this terminology, so it fits their processes very well, and it fits the quasi-experimental ones fairly well, and the descriptive ones very badly, because they basically made up the symbols. That's just my view. But this quasi-experimental thing covers most survey research. So we go and run a survey, collect a whole bunch of data, and then try and analyse it afterwards. That's really just observational. Many factors can't be experimentally controlled. So either society or nature or politics or culture allocates these factors. So you need to use really sophisticated techniques to try and pick out the different cause and effects that various variables may have contributed. So during this semester you'll learn about the regression, ANOVA, analysis of variance, that stands for, just to simulate the control variables and let you get some insight into the counterfactual, what would have happened if there weren't all these other things interfering. and what would have happened if the thing you're interested in had been present or not present. Data requirements are high because, unlike just measuring, okay, have they got toilets or not and what's the attendance rate, you have to measure a whole billion other things as well that might be interfering with it. There's time series, which means you need data across time, cross-section, which means you need data across lots of different individuals, and then panel, which means lots of different individuals across time. So you can rapidly get big, complicated data sets. But all that fun lies ahead of you with this data. For now, we'll just conclude that there is a whole range of quantitative research designs, and it goes all the way from simple descriptive designs up to really sophisticated statistical-based designs. Everything from just a low-cost village survey to a massively high-cost randomized controlled trial. The question is, if you can't randomize, are quasi-experimental designs a good enough substitute for that? So, as an overview of what's coming up ahead, the descriptive designs we'll carry on with in week 2 next week, and then we'll move into randomized controlled trials in week 3, which is that's where a lot of the action has been at in recent years. And then where you can't do pure RCTs, or the methods you need to analyse the data from those, and where you can't do them, you move on to in the rest of the week. So particular methods for analysing the data you're going to from weeks 4, 5 and 6 on. So that's what lies ahead. But for now, some list of the references, and thanks very much. Questions, please let me know through the channels that we've set up or in the live session. But for now, thanks for watching.